Hello, human geographers. We are back at it again this evening. Tonight we're going to be looking in the past. We're going to be talking about some theories from the past, some of the modern interpretations on these, and then we're also going to talk a little bit about the future, project things out, look at some trends, and kind of speculate about what we're going to be looking at. As usual, before we can really start on that, we have to have some underlying vocabulary, and so that's what we're looking at right here. So, we start out with the demographic equation, which is the formula that calculates population change. The formula finds the increase or decrease in a population. The formula is calculated as follows: births minus deaths plus or minus net migration. So as you can see there, we simplify it a little bit. It's basically crude birth rate minus crude death rate plus whatever immigration. All right. If you have immigration or emigration, whatever migration you have, and then that gives you the overall population growth or decline. And then there is a term that we need to be familiar with. It is called zero population growth, ZPG. And this is defined as the decline of the total fertility rate to the point where the natural increase rate equals zero. It does not mean that the TFR is zero, because that means that no women are having kids, people are still dying. That would be population decline. This is the point where natural increase rate is zero. So the number of births canceled out by the number of deaths. We'll talk about that a little bit later. There are some demographers that predict that global ZPG will be achieved by the end of this century. We will get to the point where we are no longer growing as a planet. And some countries are already in decline, as we talked about in the demographic transition. And so there's some other ways that we can see population growth calculated. Some of them are vocabulary terms, so let's go ahead and introduce some of those. The census, all that is just a complete enumeration of a population. So they try and count everybody. That's a way to measure population. Another one is the natural increase rate, or NIR. Again, as a refresher, the natural increase rate is the percentage growth of a population in a year, computed as the crude birth rate minus the crude death rate, and then converted into a percentage. The natural increase of a population does not reflect migration. So that demographic equation, it factors in migration, so that's how demographic equation and natural increase rate are a little bit different. And natural increase rate is typically within a year, because crude birth rate and crude death rate both calculated as a year. And then the last way that we can measure it is through doubling time. Doubling time is the time that is required for a population to double in size. And this is a range of years. Now, I will tell you guys that I think that you will need to be able to do some math on the AP exam. It's not going to be super difficult, but some basic addition, subtraction, multiplication, division, that is something that you might have to be able to do. And so one of those examples is the rule of 70. Now, there's another textbook that calls it the rule of 72, so don't be surprised if you see it that way. The formula works the same way, all right? All the rule of 70 is the equation that is used to calculate the doubling time. So basically what you do is you take the number 70, or 72 if it's the rule of 72, and you divide it by whatever the growth rate is. You don't have to convert it out of a percentage. You don't have to do anything like that. It's very simple. 70 divided by whatever the growth rate is. That will tell you how many years it will take. So here's the tricky part. The higher the growth rate means that they will double in time, they will double faster, which means that it'll actually be a fewer number of years. So if you're growing more quickly, you'll double in a shorter amount of time. Whereas if you are growing more slowly, a smaller growth rate percentage, then it will take more years to double in time. So let's give some examples to help with us. So if you are growing at 2%, 2% is actually a fairly significant growth rate. We take 70, we divide it by 2, it would take 35 years to double in size. That's all you have to do. You don't have to convert it out of a percentage. You don't have to do anything like that. Very simple. 70 divided by 2. So let's give some of the more common natural increase rates, growth rates, I should say. So that way you have some basis for comparison. All right. So we already gave 2%. Go ahead and calculate what it would be for 1%. This one should be fairly simple. I'm not a math guy, but 70 divided by 1, that's still just 70. So it would take 70 years to double in size. And if a country is growing at 0.5%, good example would be the US. The US is growing at about half a percentage point each year. That would take about 140 years to double in size. So just kind of know those that way. And I do think it's possible that you could have to calculate that on the AP exam. So maybe it's like a multiple choice question. Just be prepared for that. What all of this is building towards is overpopulation. All right. We have all these metrics to evaluate population growth, the equation, doubling, time, natural increase rate, all that kind of stuff. But ultimately what that comes down to, what is the importance of this? Are we overpopulated? And so we need to know what it means to be overpopulated. Here's the definition. The number of people in an area exceeds the capacity of the environment to support life at a decent standard of living. So we see that term capacity. What capacity do you think they're talking about? You're right, carrying capacity. So we can actually modify that. Exceeds the carrying capacity. And remember that the carrying capacity is just the population level that can be supported given the quantity of food, habitat, water, and other life infrastructure present. So essentially what overpopulation is too many people compared to the resources in a region. But here's where things start to get tricky. And we mentioned this in our density lecture, but let's review it again. Adjusting the way in which resources are consumed adjusts the carrying capacity and thus whether or not a region is overpopulated. For example, one of the approved human geo textbook argues that Western lifestyles, meaning the way that we live here in the US, Australia, Japan, European countries, things like that, if they are adopted by large population countries, think China, India, then we've already exceeded the carrying capacity of our planet and our world is overpopulated. And we'll soon start to degrade our air, soil, water quality that we depend on. How can we figure that out? Well, for example, the US, which makes up about 5% of the world's population, we use 25% of the world's petroleum. 5% of the people use 25% of the petroleum. What happens if China, which is 20% of the world's people, started to consume petroleum at that same rate? That's a concern. That's a big concern. All right? And as countries industrialize, the likelihood of them consuming like that is only going to increase. So we have to evaluate all the ways that we use resources in this world. And one of the first people to be concerned about overpopulation was this man, Thomas Malthus. And this is absolutely a name that you are going to need to know. They've actually had an FRQ question on the AP Human Geo exam about Thomas Malthus. Now, I don't think it's very likely that they could have another one, but you never know. It's possible. I would more expect it to be a multiple choice question or for his name to pop up as an option on a multiple choice question, whether it's correct or not. And so you absolutely need to know his name. And so that's why he's one of our vocabulary terms. Here's the definition that we use. One of the first to argue that the world's rate of population increase was far outrunning the development of food production. And so the biggest thing that Thomas Malthus was concerned about was population growth rate and food. Those were the two variables. Those were the two things that he was concerned about. And he first talked about it in a piece that he wrote and revised several years called An Essay on the Principle of Population. That's when he first came out with this. And essentially what he argued, and this is what you need to know, population grows geometrically, food grows arithmetically. And we'll visualize this on the next slide. But Malthus basically believed that a population that outstripped its food supply, grew past its ability to support itself, would have some kind of check on population. All right? Whether that is famine, disease, war, and what would eventually happen is when they pass their ability to feed themselves, there would be some kind of check, a bunch of people would die, and then you would get back under carrying capacity and not be overpopulated. That was his argument. So let's take a look at his theory. All right, so what we have here is a visualization of Malthus's theory. So the red line, that is population. The green line, it's labeled as resources, but we actually know from his theory that he was concerned with food. And so, according to Thomas Malthus, population grew geometrically, what is often labeled as exponential growth. That 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16, so on and so forth. All right, that's geometric growth. Okay, and his argument was that food grows arithmetically. What is constant growth? 1 becomes 2, 2 becomes 3, 3 becomes 4, 4 becomes 5. And you can see how very, very quickly population would surpass the food. And so this is the underlying principle, and you will need to know this for Thomas Malthus. On a quick side note, notice that population curve. That's a good J curve. Good example of a J curve. So what's influencing some of these beliefs that Thomas Malthus has? Well, there's two major events that we have to talk about. The first is the Industrial Revolution. Mid-1700s into the 1800s, you've got the Industrial Revolution, and that's improving sanitation, it's improving medical care, it's preventing disease through things like the smallpox vaccine, and really what that's doing is meaning that fewer people are dying from preventable diseases. And so that's bringing the crude death rate down, but if you bring the crude death rate down by preventing disease, and you don't have the food to feed them, then they don't die from disease, but they die from starvation. So at the same time, the second agricultural revolution is going on, and that's increasing the amount of food. So we can support those increasing populations, all right? And so we start to see better farming methods, which are increasing crop yields, things like the 4-field rotation method. So we're using more land area and using it in different ways. New crops. Something like potatoes. And you're like, wait, potatoes are a new crop? They were to Europe. Because until the Columbian Exchange, there were no potatoes in Europe. Potatoes are native to South America. So we're starting to see new crops be utilized, and utilized very effectively to feed a lot of people. And we'll obviously talk about the Irish potato famine later, but that was something that Thomas Malthus was looking at too. And then we also saw improvements in storage and distribution, and it's important to understand that things like grains can be stored for much longer periods of time than can fruits and vegetables and meat and things like that. And so that's starting to alleviate some of the population pressures from a food standpoint. All right, so let's take a look at some of the evidence that might support Malthus's decision. All right, we'll start out with population has been growing very, very quickly, all right? And there are a number of reasons to explain this. One of those are going to be policies that support a growing population. One really famous example is Mao Zedong in China after the Communist Revolution there says, for every mouth, they have 2 hands. And so he actually supported population growth before they went, oh, whoa, we're growing really fast, all right? And so he actually encouraged that, all right? Countries that are in stages 2 and early stage 3, they're growing dramatically. There's lots of population growth that takes place during stage 2 and early stage 3. And countries that might limit the use of family planning. We'll talk more about family planning later, but if a country limits family planning, that can absolutely lead to more rapid population growth. And on the flip side, the food element of this is that while the food supply has increased, it hasn't been enough to keep up with future population growth. If we continue growing at the rate that we are growing or have grown in the past, our food won't be able to keep up, all right? And so there are a lot of reasons why we might not be able to keep up. The lack of innovation, agricultural land being converted to urban land use. This is one that I like to talk about. Chicago is a really great example because Chicago continues to grow and grow and grow. And if you take a look at the land that they're growing onto, this is some of our best agricultural land. And so as cities continue to grow, where are they growing to? They're growing onto our farms. So we're losing farmland so that people can live in cities, right? Environmental factors are something that have to be considered because, like, for example, the soil in the Amazon is really not very productive farmland. Most of the nutrients are tied up in vegetation. And when those trees are cut down, that land is only productive for a few years and then has to be left to sit there fallow for decades before the trees grow back and they can do it again. Right? Countries focusing on cash crops, cash crops meant for export, and climate change, decreasing agricultural efficiency. If climate change continues, if global temperatures rise and sea levels rise, Bangladesh loses most of its agricultural land. This is something that can be of concern and that might support Malthus's theories. So let's talk about a different group that shares some similar beliefs. These are the Neo-Malthusians. So anytime you see the prefix Neo, it essentially means new. They're the new Malthusians. And so this is kind of a bit of stimulus diffusion because they're taking the underlying principle of Malthus, but they're modifying it a little bit. And the biggest thing that they modify is that it's not just food we should be concerned about. All right. Now, there is a very famous Neo-Malthusian that I think you might need to know. His name is Paul Ehrlich. That's E-H-R-L-I-C-H, Ehrlich. And in 1968, he wrote a book called The Population Bomb. Now, let's keep in mind the context within which Paul Ehrlich was living when he wrote this book. In 1960, we had hit 3 billion people. Ehrlich publishes his book in 1968, so we were more than halfway to our 4th billion person on this planet. Now, side note, this graphic also shows projections, and so it needs to be updated because we actually hit 7 billion people in 2011. This predicted 2013. And it's projected that we will hit 8 billion by 2023 rather than 2028. All right? And so it's important to understand that we have to modify some of this information. Now, the Neo-Malthusians actually make a case that things are worse now than when Malthus was making his case. And there's 2 big things that they are concerned about. One of them is that LDCs are progressing due to outside assistance from MDCs. Let's clarify what we mean by that. All right? MDCs are coming in with medical technology, medical advancements, malaria nets, things like that to help bring down the death rates, which is great. It's an improvement from the demographic side. But we aren't seeing comparable improvements on the developmental side. Countries aren't industrializing as quickly. They don't create as many jobs for the populations that now are surviving because of these medical advancements. And so the concern is, if you don't meet these demographic improvements with similar economic improvements, we're going to be in trouble. And in addition to that, it's other resources rather than just food alone. And so the Neo-Malthusians look at environmental destruction with the degradation of soil quality, air quality, deforestation, the expansion of desertification, the lack of available land for people, non-renewable energy resources, and perhaps most important, access to water. So those are some of the concerns of the Neo-Malthusians. So what about those folks that don't agree with Malthus, that criticize Malthus? Sometimes they are called cornucopians, so make sure that you're familiar with that term. That is a term that is anti-Malthus. Okay? So what is some of the evidence that might support what the anti-Malthusians, the cornucopians, say? Well, one, they argue that growth hasn't been geometric, and really what they mean is that growth hasn't been exponential. It hasn't been exponential growth. And there's a couple of reasons for that. Policies that limit growth, we'll call those anti-natalist policies here in a few minutes. To juxtapose that, we talked about Mao Zedong as a policy that encouraged growth. Well, then China instituted the one-child policy, and that is a policy that would limit growth. All right. Stages 3, 4, and 5 of the demographic transition, especially late stage 3, and then 4, and then 5 is population decline. So that certainly is evidence that population hasn't been growing the way that Malthus predicted. And then the use of family planning. And we'll talk about family planning here in a few minutes, and whether you agree with it or disagree with it, that's not my spot to say what you should and shouldn't think about it, but I'm just arguing that family planning is something that limits birth rates, slows down birth rates. And so that's something we'll talk about here in a few minutes. And the cornucopians point out that the food supply has grown faster than it was predicted, right? Since Malthus's time, population has doubled 3 times. In that same time, the food production has doubled 5 times. And so in addition to just the fact that we're growing food faster, it's important to know that countries don't need to grow all of their own food. In this age of globalization, with forces of trade, as well as the legacies of colonialism and capitalism, countries can import food if they can afford it. So really that benefits MDCs more than it does LDCs, and we know that population growth is a bigger issue in LDCs, but it's something that is a reality that we have to face, is that globalization, a country doesn't have to grow all of their food. All right. And we've also seen improvements in technology, things like transportation, food preservation, machinery, as well as greater efficiency. The Enclosure Acts decreased population densities in rural areas, but provided bigger plots of land that were more efficient for farmers, especially farmers using machines. We've seen a third agricultural revolution, which included with it the Green Revolution, which made higher yield seeds, both from selective breeding as well as genetic modification. And then one person that I think is really important to mention is Esther Boserup. Esther Boserup was a Danish economist who wrote a book called The Conditions of Agricultural Growth. And essentially what she argued in this book was that as population grows, we change the way that we do things to support that. All right? And so there are a couple different ways that we could look at this. One that she really argued is that as population grows, we become more intensive in terms of agriculture. So we switch from nomadic herding to intensive grain farming to produce more food per parcel of land. So essentially, as population grows, we find a way to produce more food. And that is a good example of possibilism, that there might be limits, but we find a way to produce more food. All right, so let's go ahead and take a look at what this is. In the upper left-hand corner, what we see is a chart comparing Malthus and Esther Boserup. Now, remember that Malthus argued that population grows geometrically. Now, he argued that it would grow geometrically forever, but that was because he was in stage 2 of the demographic transition model, and no one had ever seen stages 3 and 4 when population actually levels off. Now, in addition to that, Malthus argued that food grows arithmetically. So Malthus believed that the point where population exceeds food supply would lead to some kind of Malthusian catastrophe. Think famine, disease, war, something that would bring the population back into carrying capacity, back into control below the food supply. Some people use the Irish potato famine as evidence that Malthus was correct. Now, Esther Boserup, the blue line, argues that the food supply would adjust as population increased through things like innovation, intensification, things like that. So let's see this in a real world example. This is India. Now, early on in the chart, wheat production is below population. So they have exceeded the carrying capacity as far as wheat is concerned. But then the Green Revolution happens during the 1970s in India. And we see dramatic increases in wheat and rice production in India, to the point where not only do they have enough to support their growing population in India, but also that they have enough to export. So we're going to talk about the impacts of this next lecture and how countries try and modify what they do. Have a good evening, everybody. We'll see you back in class.